On Christmas morning 2021, a rocket lifted off from a jungle launch pad in French Guiana. Folded inside its nose cone was the most expensive scientific instrument ever built, $10 billion. 30 years of work, and a mirror so large it had to be folded like origami just to fit inside the rocket. Astronomers around the world held their breath. 344 things had to go perfectly right. A single failure, and the James Webb Space Telescope would become the most expensive piece of junk in the solar system. Every one of those 344 steps worked, and 18 months later, the telescope began sending back images that broke our understanding of the universe. To understand why Webb matters, you need to understand what it actually does. Webb doesn't see light the way we do. It sees infrared, the heat glow of the cosmos. And that changes everything because the universe is expanding. Light from the most distant galaxies has been stretched during its journey to us, shifted out of the visible spectrum and into the infrared. The oldest light in the universe is invisible to our eyes and to Hubble, but not to Webb. There is something else. Infrared light passes through dust, the great clouds where stars are born, the veils that hid the centers of galaxies, the cocoons around newborn planets. For all of human history, these were walls we could not see behind. Webb walks straight through them. The first image was released in July 2022. It was called Webb's First Deep Field, and it covered a patch of sky the size of a grain of sand held at arm's length. Inside that grain of sand were thousands of galaxies. Some of the light in that image had been traveling for over 13 billion years. We were looking at the universe as it was when it was a child, and that is where the trouble started. Webb found galaxies that should not exist. Massive, bright, fully formed galaxies, shining just 500 or 600 million years after the Big Bang. According to our models, the early universe should have been building small, faint, fragile things. Instead, Webb found metropolises where we expected villages. Astronomers called them the Impossible Galaxies. The discovery didn't break the Big Bang theory, but it did something almost as dramatic. It told us that the young universe worked faster and harder than we ever imagined. Somehow, in the cosmic blink of an eye, gravity assembled billions of stars into ordered galaxies. We still don't fully know how. That question is now one of the biggest open problems in astronomy. Then came the Carina Nebula. When this image was released, it looked less like data and more like a landscape. Cliffs of gas and dust, 7 light-years tall, glowing at the edge of a cavern carved out by the radiation of newborn stars. Inside those cliffs, Webb could see what Hubble never could. Hundreds of infant stars, still wrapped in the dust they were born from, firing jets of gas into the dark. Star birth was always a theory we trusted, but could barely watch. Webb turned it into something we can observe directly, star by star, jet by jet. It is like the difference between reading about a birth and standing in the delivery room. Webb also turned its mirror toward an old friend. The pillars of creation, made famous by Hubble in 1995, are perhaps the most recognizable structure in the night sky. In Hubble's image, they are majestic, opaque towers. In Webb's image, they become translucent. The dust thins into mist, and suddenly you can see through the pillars, to the young stars burning inside them, glowing like embers in smoke. Look closely at the edges of Webb's image, and you can see something remarkable. Small, bright red knots and wavy lines. Each one is a star in the actual moment of formation, ejecting material as it collapses. These pillars are not monuments. They are factories, and Webb caught them running. Then there are the deaths. The Southern Ring Nebula is the corpse of a star like our Sun, its outer layers blown into space in glowing shells. Webb's infrared eyes revealed the dying star itself, hidden in dust at the center, and showed that it wasn't alone. There were at least 2 stars locked in the dance that shaped those shells. Every shell is a chapter in a story that took thousands of years to write. Our own Sun will write one of these stories. 5 billion years from now, Webb also watched galaxies collide. In Stephan's Quintet, 4 galaxies are locked in a slow gravitational war, pulling streams of stars from each other's bodies. Webb captured shockwaves larger than our entire galaxy and gas being squeezed into new generations of stars by the violence. Galactic collisions are not destruction. They are the universe recycling itself. And then there are the worlds. For the first time, we can read the atmospheres of planets orbiting other stars. When an exoplanet passes in front of its sun, a tiny fraction of starlight filters through its atmosphere, and Webb can decode it. It has found water vapor, carbon dioxide, sulfur clouds, and rain made of sand on worlds hundreds of light-years away. The real prize is a small system called TRAPPIST-1, 7 rocky planets, 3 of them in the habitable zone. One by one, Webb is checking them for atmospheres. It is the first time in history that the question "is anyone out there?" has become a measurement instead of a dream. Step back and the pattern is clear. Webb hasn't just given us prettier pictures. It has rewritten timelines, opened nurseries and graveyards of stars, and turned the search for life into laboratory work. And here is the astonishing part. The telescope was designed for a 5-year mission. Its fuel, thanks to that flawless launch, may last 20. Every image you have seen in this video is real. Real light that traveled for millions or billions of years and happened to end its journey on a golden mirror floating a million miles from Earth. The universe has been sending us these letters forever. We only just learned how to open them. If this journey through Webb's discoveries moved you, consider subscribing. The telescope is just getting started, and so are we.